Okay, let's take a look at some of these ideas with coordinate geometry proofs. And proofs is used a little bit loose here, but the general idea is that we have evidence that kind of matches the claims that we're making. So we're going to do this pretty structured and strict here, where what we're saying that we have, for example, a scaling triangle that's not right. It's instead of saying what kind of triangle is it, I'm telling you what it is, but then we're going to talk about the evidence that shows that. So first, scaling means that there are no equal edges, and if it's not a right triangle, then it's going to have no right angles. Now I have these 3 points here, and I could plot them on this graph drawing there, but I'm actually going to switch over and use the Desmos geometry tool. It just makes it very easy to use as we work our way through it. So let's say that I have these 3 points, and I'll just put them in here as X and Y coordinates. So we have 7, 1. We also have 5, 8. 5, 8, and then the last one is 0, 5. So I have these 3 points. Now it's kind of hard just to tell with this bit of information, so let's make it a little bit easier by turning on the grid and the axes, and now we can more precisely see where those things are. I'm going to use this tool here, which is the shape tool or the polygon tool. And then I can click on these 3 points as such. Now there's a few things that we can look at. One of them is the angle measures of all the corners. And I'm going to click on the angle measure tool, then just click in the middle of the triangle. And I notice that all 3 angles are unique. That's helpful. Now I want to measure each of these edges here. So I'm going to measure that one, there, and there. And right now, the way the geometry tool is, as I'm recording this video, we have to kind of create a segment for each of those 3 points, right? But once I've done that, I could click on a segment, and I believe if I label it, yeah, if I turn on the label for each of these segments, it will give me those side measures. Rounded off, of course, as well as these angles are rounded off based on this tool. Okay, so now I have all my information. I have 3 sides that are not equal, no angles are equal, and I've plotted the 3 points. I could even label these 3 points where it does it there. Let's see if I can do it slightly different. I believe if I click on this label, yep. So if I click on these label boxes, and for those 3 points that I put in there, it gives me where the 3 points are and all these measures that are created from the triangle that surrounds it. So then I can just screenshot this here, and it gives me an example of that triangle. So I'm going to remove that and put in, whoops. Let's try that again. We will screenshot. But this time we're going to have it go to the clipboard and capture it, and then we'll paste it in there. Perfect. And in fact, what I'm going to do for the notes in this is I'm going to delete this last column. There are ways that you can calculate such things, and you know what? We'll leave that in there because there are some things that we can do. All right, an isosceles triangle. We're going to have at least 2 equal edges. But most often just 2 equal edges. And right angles, none, because it's not a right triangle. Here is what's so cool. I don't have to redo this entire graph after the first one that I made. I could just adjust these points. So for the first point, it's at -8, 6. So I'm going to put in here -8, 6. And now it's already adjusted that point. N is -7, 2. So -7 and 2. And the O, or the last one there, is -1, -2. -1, -2. Now my triangle is a little bit off to the side. And And I'm noticing it looks like these numbers are incorrect. Let's see if we double check them. Ooh, this -8 is supposed to be -8, -6. All right, now we do have an isosceles triangle, and I notice that I have these two sides matching, and their two opposite angles are matching as well, which is great. That's what we were looking for. So let's snapshot a picture. We're going to keep on going through creating these different triangles, but confirming with these side measures and angle measures that we have these things. All right, a scaling right triangle. A right triangle means it's going to have a right angle, and triangles can only have one right angle in a flat plane like this. But for equal edges, if it's scaling, that means 0 equal edges. Let's see what this looks like. Let's put in these three numbers. We have -4, 0. So, and I could even, can I do this? Oh, I can. I can just copy and paste. Love shortcuts. So -4, 0. We have -5, -4. Paste those in. And then the last one is 3 and 6. Okay, we have a right triangle, but all three sides are unique. All three angles are unique, which is great. That's what we want. So we will take a snapshot of this, capture it. We're going to paste it in here. Perfect. An isosceles right triangle. Okay, that means we're going to have isosceles means 2 equal edges. And a right triangle means that we're going to have one right angle. Let's see if that winds up being true. We're going to copy and paste these x and y coordinates over here. And we have 0, -2. And then -1, -9 for our final point. And in fact, we do have a right triangle. And 2 of the sides are congruent, and 2 of the angles are congruent. The only way you're going to get an isosceles right triangle is if you have 45 degrees and 45 degrees. So let's snapshot this picture. And we will paste it in here. Perfect. Now let's talk a little bit about quadrilaterals. So I'm going to go ahead and start a new page with this graphing calculator. I can always just go to desmos.com and it'll be under the math tools. There's the geometry tool there, but we are using this beta version. A square is going to have 2 pairs of equal edges, 4 right angles, and 2 pair of opposite sides are parallel. Let's see what that looks like. So I'm going to put these points on the screen. So we have -2, 5, -8, 3, -6, -3, and 0, -1. Awesome. Okay, let's turn on our grid and the axes so we can see a little bit better of where we are on a graph. We're going to create a polygon. Using the polygon tool, and we're also going to trace the line segments around each edge. So I got to click on these points. Got to click the start and finish every time. So I click start and then I click finish, I click start, and then I click finish. So now I have segments, I got a polygon here. We're going to add angle measures, so I click on the angle measure tool and I throw it there in the middle. And then we're also going to click on these edges and the 3-dot menu and choose label, and that will give us those side edges. Perfect, perfect, perfect. There we go. And then now what else do we need? I think there's one more thing. Oh, are they parallel? Yeah, let's do some things like this. So we're going to create some lines, and this is the easiest way to visualize being parallel. Those two lines will be parallel, and these two lines will be parallel. So sometimes they're going to be parallel, and sometimes they're not. In order to make it just as clear as possible, we're going to, let's say, color these ones purple. We'll color the other blue lines green. So we got purple. We'll change the purple to red, make it a little more contrasty on the screen for everybody. There we go. So now I have red lines, green lines, and a square. So we have two pairs of equal edges across from each other, 4 right angles, and this as well. So this is what's interesting. A square has this, and it's not just, but a rectangle based on this definition is the same. It's the same. So that's kind of interesting. What we could also add in here is all 4 sides equal. So I'm going to add that in there because that makes a square different than a rectangle. And we'll take a picture of this, capture it. I'll replace this graph with my picture. Now let's try to insert in these other points to see what makes something the other kinds of quadrilaterals. Make this picture a little bit smaller, save a little space there. Okay, a rectangle also has 2 pairs of equal edges and 4 right angles, and 2 pairs of opposite sides are parallel. Let's see what that looks like in here after we copy and paste some of these numbers. So I'm going to copy the first X and Y coordinate, paste it in there, and then we'll copy the second one. -7, -5. Paste it in there. Copy the third one. -3, -6. Paste it in there. Oh, we got an extra parenthesis. And -1, 2. That does look like a rectangle. I noticed that I have 4.12, 4.12. 8.25, 8.25 in terms of equal opposite edges, and 4 right angles, and definitely parallel lines. So I'll take a picture of this one, capture it, paste it in, shrink it down just a little bit. Now let's look at a rhombus that's not a square. So it has 2 pairs of equal edges. It does not have any right angles if it's not a square. And opposite sides are parallel. And we're going to also say in here, all sides are equal on a rhombus. Again, let's copy and paste in our X and Y coordinates. Go 9, 1, and 0, -1 for the last XY coordinate. There we go. That's a rhombus there. So we got 9.22 all the way around. The red lines are parallel, the green lines are parallel, but we don't have any right angles, and that's kind of the move that we were looking for. So let's capture a picture of all this. We can paste it in. Perfect. A parallelogram that's not a rectangle. So for a parallelogram, you're going to have 2 pairs of equal edges, no right angles, and 2 pairs of opposite sides that are parallel, but not all sides are equal. So let's create this. We'll copy and paste it. Whoops. Looks like we took it away from there. Let's just copy instead of cut. There we go. -9, -8. And the last one is 0, -4. Ooh, looks like we have something off. So we have 1, 1, -8, 3. I think this is supposed to be a -3. Let's see what that does for us. Yep. So that was supposed to be a -3. That's a typo, but we'll have it fixed for you all. This gives me 2 pairs of parallel lines that are not intersecting. And we will capture this so that we can paste it in over here. And then we're going to put in our last one here, but I'm going to leave it for you to do that one. On a generic quadrilateral, you're not going to have any pairs of equal sides. Maybe one pair, but usually not. You might have 1, you might have 0 right angles, but you won't have any pairs of opposite sides parallel. So the first 2 are kind of optional, but that last one has to be no pairs of opposite sides are parallel. Go ahead and copy and paste these in, try to capture and insert the image in there, and then you'll be done.